All right, welcome back. Today we're doing the Math 3 9.7 notes, solving without common bases. All right, so how do you solve exponential equations that do not have common bases? Okay, now first of all, when are we going to get something like that? Well, if we have a problem like this, log of 150 base 3, well, I can put that in exponential notation, and then I get 3 to what power equals 150, but I can't write 150 as 3 to a power. And I can't write 3 to a power as something else to a power. It's too small of a number, right? It's a prime number. So anyways, how do we solve something like this? That's what we're going to figure out today. Okay, because if I wanted to know between what two consecutive integers will we find our answer, well, I can figure that out. We can say, all right, I know 3 to the first power is 3. That's too small. And then 3 to the second power is 9. That's too small. 3 to the third power, we get 27. That's still too small. 3 to the fourth power, we get 81. I'm getting closer, but that's still too small. And then 3 to the fifth power, well, that'd be 81 times 3, so that'd be 243. Well, that's too big. So 3 to the fourth is too small, 3 to the fifth is too big, so then we know our answer is going to be between 4 and 5. Okay, so that's pretty good. We're getting closer, but I want to know exactly what is it? 4 point what, in other words, instead of just between 4 and 5. So to get more exact, we can use our calculator. Okay, so let's take a look at a scientific calculator. If we look at our scientific calculator, a couple things should look familiar on here, and don't worry about the screen right now. Let's just look at the calculator part. On your calculator, you're going to see a log button and a natural log button. Okay, great. So then we can take the log of something, which if there's no base written, that's base 10. And natural log, of course, is base e. Okay, so then I can use my calculator when things are in base 10 or base e. Oh, but what's wrong with our problem here? Well, this isn't base 10 or base e, this is base 3. Well, you can look all you want, there's no base 3 button on here. Now, some of the fancier or more expensive calculators might have an option where you can change the base. Most of your calculators won't. A regular scientific calculator is just going to have log and natural log. Okay? All right, so how will we solve a problem like this then? Oh, sorry, screen's jumping around. Let's zoom in a little bit. All right, so like it says here, since log of 150 base 3 is not written in base 10, we're going to use the change of base theorem to let the calculator work. Now, we don't have to use just base 10. We could also use base e. Okay, natural log works just as fine. Most people just are afraid of writing less letters, I guess. Okay, because natural log would actually be less to write. So you can use either one you want. It doesn't matter which one you choose to use. Okay, you can use natural log or log base 10. All right, so how does the change of base theorem work? How can we change our base? Well, basically, it works like this. If we have something like the log of b base a, how can we rewrite that with a different base? First of all, again, you can pick any base that you want. So I can take this thing and write it as 2 logs. Okay, and those 2 logs are going to become a fraction. You're going to have a log on the top and a log on the bottom. It's the change of base. We're doing this so that we can pick a new base. So then it's going to be log base c. I maybe should have left a little more space there. Log base c. Again, c is just for whatever base I choose to pick. And then where are the b and the a going to go? Well, your base is going to stay in the basement down low. Okay, so the base, the a, is going to stay down in the basement, stay down low. And then your number that's higher up is going to stay higher up. So then I can rewrite this thing as the log of b base whatever I want over the log of a base whatever I want. And if we choose base 10 or base e, well then I can punch this thing in a calculator. Okay, so back to our original problem here. If we have the log of 150 base 3, how can we rewrite that so that we can punch it in a calculator? Well, again, I want to write it as a log of log. And if we're choosing base 10, then I don't need to write a base, so that's good. And then my base stays in the basement down low, so log of 3 goes on bottom, and the log of the thing on top goes on top. So I can rewrite that as the log of 150, which is just a number, divided by the log of 3, which is a number, and our calculator can work that out for us. Okay, or we're going to get the same exact answer, and we'll look at both real quick because it doesn't take very long. I could also write this as the natural log of 150 over the natural log of 3. Okay, so it doesn't matter if I use base 10 or base e, my calculator is going to give me the same answer. Okay, so let's take a look at our calculator now and work this one out. Try to get where there's no glare and where we can see our stuff. All right, so I want the natural log of 150 over the natural log of 3. Now, depending on your calculator, you might want to use parentheses, might not. It's always safe to use parentheses. So I can use parentheses and do the log. We'll do base 10 first of 150, and then close around the number that I'm taking the log of, and then close parentheses around the whole top part, and then divide it by the log of 3. And keep in mind, what should we expect for an answer? I forgot to put parentheses on the bottom because I was talking. Whoops, not 33, 3. What should we expect for an answer? Well, we know it's going to be between 4 and 5. So let's see if this is what that gives us. Yeah, so 4.56. So yeah, that's pretty close. And then we wanted our answer rounded to the nearest, what was that? They didn't say, let's just go the nearest, maybe hundredth. So 4.56 ought to work just fine. So then this stuff is actually approximately 4.56. Okay, now let's go 4.561. So we'll go to the nearest thousand. Okay, all right, let's leave that answer on this calculator now. Let's look at what if we use natural log? Would it give us a different answer? And then we'll know that they're the same. We can just pick one from here on out. Okay, so if I did the natural log of 150 divided by the natural log of 3. Okay, so hopefully you can see that on your screen, but it gives us the exact same answer, 4.5608766795, keeps on going. Okay, but it is the exact same answer, so it does not matter if you use log base 10 or natural log, it's just your preference. Most people usually choose log base 10 because for some reason we're scared of natural log, but it's actually left to right. Okay, so it's a little bit simpler. Okay, but either one will work. All right, important thing is being able to change from one base to the other. Okay. All right, next we're going to use our change of base theorem to rewrite the given logs into the indicated bases. So we're not solving things here. This is not something we can punch in our calculator. But let's say we had log of 11 base 6, and we decided, okay, we want to write that in base 7 for whatever reason. Okay, if I wanted to write this thing in base 7, so in other words, if I want to write this and change the base, well, I know it's going to be a log over another log. Okay, so write that part first. What do we want our new base to be? Well, base 7. So then put a 7 down here in the base, 7 down here in the base. And then remember, the 6 that was our old base stays in the basement, stays down low. And then the 11 stays on top. Okay, so then I could rewrite this thing in base 7 like that. And then that's all they wanted us to do. Okay, well, what if we wanted to write log of 90 base 2 with a new base of 5? Okay, well then that'd be the log of 90 base 5 over the log of 2 base 5. Okay, so again, this wouldn't do us a whole lot of good if we're trying to use a calculator. We're just practicing changing the base to whatever we want. Because again, we can change it to 10 or E or 7 or 5 or anything else that we want. Okay, all right, now let's do that backwards. We want to express the following things as a single log. Let me try to zoom in a bit. All right, so think of it this way. We started off with some log statement and someone changed it into base 4. Well, how can we undo what they did? Okay, now you can just try to think, okay, what was my original base? That's the thing in the basement, 5. And then I was taking the log of what? Well, that number. Okay, so this would be the log of 10, base 5, before they made it base 4. And then whenever you're trying to change it from, well, if you're trying to go from 2 logs to 1 log like this, there's a nice little trick here. Kind of do like a backwards looking check mark. I want to cross out what they added. So what did they add? Well, they added the new base and an extra log. So if I kind of just do a little backwards L like that, then I get what I originally had, log of 10 base 5. Okay, so on the next one here, someone changed this other statement to log of something base 8 over log of something else base 8. Well, I want to get rid of what they added. I want to get rid of the new base they added and one of the logs. So what's that leave us with? Log of 25 base 5. Okay, and then this one works out nice. If I wanted to simplify this, 5 to what power is 25? Well, we can answer this one, it's just 2. Now, they didn't ask us to simplify. They just said express as a single log. So this is all we were looking for, but, obviously the answer would be 2. Okay, so we can change the base if we want to. Mainly we do that whenever we want to solve and get an answer in our calculator. All right, now let's see how this stuff is actually applied. I don't want to zoom out again, so let's just read the instructions here. So it says solve for x, write your final answer in terms of logarithms in 2 different ways, then evaluate your answer using a scientific calculator and round your answer to the 1,000th place. Okay, so we want 3 decimals there. All right, so then how would we solve something like 3 to the x equals 12? This is those, like it says on the front page, now we're solving without common bases. Because I can't get a common base between 3 and 12, there's no number that works. Okay, so then how do we solve this? Well, there's a couple ways, and we'll look at a couple different ways of solving. Okay, one thing that we want to remember when we have a problem like this, and I'm going to rewrite it, 3 to the x equals 12. I'm leaving a little space here. Logs are just like any other mathematical operation, like addition, subtraction, division, multiplication, square roots. So, I can divide on both sides of my equation. I can square root both sides of my equation. Well, I can also take the log of both sides of my equation. So we can take the log of both sides of our equation just like we can divide on both sides of our equation. Now I'm not writing a base because I like it base 10, because eventually we want to punch this in a calculator. Okay, so I want to take the log of both sides. Now, what good does that do me? Okay, well, I don't like having x up in the exponent, but now that I have the log of 3 raised to the x, well then we can use our third log rule that we learned, and I can take this x and put it down in front. So then that gives me x times the log of 3 equals the log of 12. Now, when you're doing these problems, the important thing to keep in mind, log of 3, well, that's just some number. That's 10 to what power equals 3. Log of 12, that's just some number. It's 10 to what power equals 12. Okay, so then I have x times this number equals that number. Well, how do I get x by itself? Well, it's the opposite of multiplying by that number. Divide by that number. So we want to divide both sides by the log of 3. And then here, well, these reduce, so those go away. And then I get x equals the log of 12 over the log of 3. Okay, and if we're solving without a calculator, well, that's our exact answer. Okay, so this is one way to write it. And then what would that answer be? We'll just punch that in a calculator. Try to get where you can see without a glare. Hopefully you can see that. All right, so we want the log of 12. So log 12 divided by the log 3. And also, before you hit enter, think, well, what should our answer be about? Well, 3 to what power is going to give me 12? Well, 3 to the second power is 9, that's too small. 3 to the third power is 27, that's too big. So then it should be 2 point something. So when I hit enter here, we should get an answer of 2 point something. And yeah, 2.261. So yeah, that looks good. That's about what we expected. We want to round to the nearest thousandth, so then we'll go 2.262. So this is approximately 2.262. Okay. All right. Now, real quick before we move on to the next problem, they said write your log expression in 2 ways. Well, here's one way: log of 12 over the log of 3. Now, another way we could have done this problem from the very beginning. Let's rewrite it. We'll keep it on the side so we can see. But we had 3 to the x equals 12. Well, another thing we can do is kind of, imagine this is the second step of our problem. Someone put it in exponential notation for us. Well, how did it start off as a log? Let's write this thing as a log instead of an exponential notation. So let's see. We had to have a log. What was our base? What's the thing raised to a power? Well, 3, so then that would be our base. Okay, and then equals, so it's 3 to the x, so that's the x is going to be our exponent, and then 12 would be the number we're looking for here. Okay, so if we put this in exponential notation, this would be 3 to the x equals 12, and then yeah, that's what we started with. Okay, so then that works. All right. All right, moving on to the next problem. So we got 5 to the x equals 40. So 5 to a power equals 40. So first of all, we should be able to approximate our answer. I know 5 to the second power is 25. That's too small. 5 to the third power is 125. Well, that's too big. So again, our answer should be 2 point something. Okay, but how are we going to get there to that 2 point something? Okay, so we can do it just like we did the last problem. So let's see. Let's rewrite this. Oops. So we got 5 to the x equals 40. I'm leaving a little bit of space on purpose. Okay, because like last time, I want to take the log of both sides. Okay, so then let's do something different than both these other methods that we did. I don't want to just write it as the original log, and I don't want to do it log base 10 or log base e. What else might be a good way to solve this problem? Okay, well, keep in mind our goal is to get x by itself, right? So then what might be a good base to choose when I take the log of both sides? What would make all this stuff go away? Well, how about log base 5? Now you might need to separate it from the other problem like me because it took up a lot of space. Okay, but if I do log base 5 on both sides, and it does have to be the same base on both sides, well then that's kind of nice because what is log of 5 to the x base 5? Well, that's just x. In other words, I can take the x, put it in front, and it'd be x times log of 5 base 5, which is 1. So then this gets me x by itself right away. And then I get the log of 40 base 5. Looks like I'm running out of ink. Switch pens here. We're going to switch to black. Okay, but let me rewrite this. Okay, so we get the log of 40 base 5. And then that is our answer. That's exactly what we want. Okay, but again, this doesn't do us a lot of good because I can't punch that in my calculator. Okay, so then let's do the change of base theorem here. This is the same as the log of 40 over the log of 5, and we're just going to leave it in base 10. Oops, sorry about that. We're going to leave that in base 10, that way I can punch that in a calculator, and then finally now I can go get my answer from the calculator. So if we punch this in our calculator, we get the log of 40 over the log of 5. And like we said, 2 point something. So we get, sorry, zoomed in kind of far here. We get 2.292. Okay, so then this answer is approximately 2.292. All right, let me zoom out a bit. I like being zoomed in so you can see, but I'm getting off screen a little bit. All right, so anyways, they wanted our log written in 2 ways. Well, here's one way with base 5, and here's another way when we change it to base 10. So then these are our 2 log answers, and then here is our decimal approximation. Okay. All right, so anyways, we have a couple options here when we're trying to solve a problem without common bases. Okay, so I have my problem, well, I can put it in log form, but then I got to change the base anyways. Or I can write it with base whatever this number is to get x out of the exponent, and that works out kind of nice, but then I got to change the base anyways. So then normally when we're solving these problems, especially when we only want to solve it one way and we don't need 2 different answers, we want to do it like we did the first one. We want to take the log of both sides, either base 10 or base e. Okay, because that's going to be the least amount of work in the long run. Okay, but again, you do have some options. You can solve it however you'd like to. All right, next one. We've got 6 raised to the x minus 2 equals 87. Okay, we're not going to worry too much about writing our log in several different ways. We've shown 3 different ways we can solve. Let's just worry about getting the answer now. All right, so I have my x in the exponent. So anytime we have our variable in the exponent, that's when we want to take the log of both sides. And then why do we have to do that? Oops, I put the space on the wrong side. We can squeeze it in there. All right, so we take the log of both sides because when I have something, the log of something raised to a power, well, we know we can take our exponent and put it in front. And that's the whole reason we take the log of both sides, to get this out of the exponent. Okay, so then I could write this as x minus 2 times the log of 6 equals the log of 87. Okay, and then remember, log of 6 and log of 87, those are both just numbers. Okay, so then I want to divide by those numbers. Well, by that number I mean, to get x one step closer to being by itself. Keep in mind x minus 2 is a binomial, which is I got to keep those together. Okay, so then that gives us x minus 2 equals log of 87 over the log of 6. So again, when you get to this step, an important thing to remember is that this whole big thing, I'm going to put it in parentheses, this whole big thing is just some number. When I punch that in a calculator, it's going to give me some decimal. And then what do I want to do to that decimal? Well, how do I get x by itself? Last step is we got to add 2 to both sides. Okay, so we're a little tight on space, so let's just put our answer. Our answer is approximately what? Okay, so we'll go to our calculator. Again, I want to figure out what this answer is here, and then just add 2 to it. So we want log of 87 over log of 6. Try to get where there's no glare. Log of 87 divided by the log of 6. And then there's our number. And again, we want to add 2 to it. We can use the calculator. Plus 2, we get 4 point, and if we're rounding the nearest thousandth, excuse me, it'd be about 4.492. So 4.492. Okay, and then there's our answer. And again, we didn't write the log in a second way, but that's okay. All right, let's go through these last 3 examples, and we'll wrap up these notes. All right, so we got the log. Sorry, I'm jumping ahead here. We got 2 to the 2x equals 48. Okay, so there's our problem. Since our variable's in the exponent, one way we can get it out of the exponent is by taking the log of both sides. I'm going to do natural log because I don't want to write as much. And I know from the first page of notes we saw that we're going to get the same answer anyways. So let's just do natural log. And we'll see it's no different here. Another thing you can do is approximate what your answer should be. Okay, what should our answer be? Let's see, 2 to the 5th is 32, that's too small. 2 to the 6th is 64, that's too big. So if we should have an answer of 5 point something. Okay, but keep in mind, it's 2 times our answer is going to be 5 point something, so it should be about half of 5 point something. Okay. All right, anyways, how do we solve this problem? Now that I've taken the log of both sides, we can take our exponent and bring it in front. And again, that's the whole reason we're taking the log of both sides, is to get this out of the exponent. So then we get 2x times the natural log of 2 equals the natural log of 48. Okay. Now, yeah, I am multiplying by 2 and the natural log of 2, but just to make it a little simpler to understand, let's just divide by the natural log of 2 first. And then I get 2 times x equals the natural log of 48 over the natural log of 2. Okay, so again, this can give me an answer in the calculator, and then what do I want to do to that answer, to that decimal? Well, then I want to divide it by 2, okay, because I want x completely by itself. Okay, another way you can show your work if you want to is I'm going to multiply by 1/2. So I'm going to take this decimal and then multiply it by 1/2. Okay, and then that's going to give me an answer of what? Okay, so again, get this answer first in your calculator, and then just divide that answer by 2. So let's take a look in our calculator. Okay, so we want to do the natural log of 48 divided by the natural log of 2. And then we get that answer, which, like we said, 5 point something. And then I want to divide that answer by 2. And then so x is about 2.792. So x is approximately 2.792. Okay, so again, an important thing to keep in mind when you're solving these problems, when you get something like this big ugly thing, well, it's just a number. Okay, all right, last 2, let's get through these. All right, so here we've got 3 times 2 to the 2x equals 81. Okay, so yeah, sure, since our variable's in the exponent, we are going to want to take the log of both sides, but I got 3 times this stuff. Well, let's get rid of the 3 first. Okay, and when I do that, we get 2 to the 2x equals, and then 81 divided by 3 is just 27. Okay, so then 2 raised to what power is 27? We can get an approximate answer. Okay, again, 2 to the 4th is 16. That's too small. 2 to the 5th is 32. That's too big, so it should be between 4 and 5. But again, that's going to be, this whole thing between 4 and 5, and then we're going to cut it in half. Okay, so here, let's take the log of both sides so we can get that x variable out of the exponent there. And again, we can do log base 10 or natural log. You can go back and forth, doesn't matter. Your calculator will give you the same answer. Okay, it's your choice. I'm going to take the exponent, put it in front, and then we're going to get 2x times the log of 2 equals the log of 27. All right, again, I'm going to ignore the 2 for a minute. I'm just going to focus on the log parts. I'm going to divide everything just by the log of 2. and then I get 2x equals the log of 27 over the log of 2. Okay? All right, so again, when I punch this stuff into my calculator, it's going to give me a big number, and then what do I want to do to that number? I want to cut it in half. Okay, so then we're a little tight on space. We're going to kind of just write the answer next. We're going to get x equals what? Let's look at our calculator here. All right, log of 27 divided by the log of 2 gives me that number, which, like we said, between 4 and 5, good. But then we want to divide it by 2. And we get about 2.377. So x is about 2.377. It should be equals instead of approximately, but that's okay. There's our answer. All right, one last one. Let's get through this. All right, so we got 4 times 6 to the x minus 2 equals 64. Okay, well, again, before we start taking the log of stuff, because I don't want to have the log of a product, that's going to be more work. Okay, let's get rid of that 4 first. So if we divide both sides by 4, then we get 6 to the x minus 2 equals 16. Okay, and then again, since our variable is in the exponent, we need to take the log of both sides. Choose natural log because it's left right. Okay, and then I don't care if I use log or natural log. I just push a button into my calculator. It does the work for me anyways. Okay, and then we have the log of this thing to a power of 6 to the x minus 2, and take that exponent, x minus 2, and stick it in front. So we get x minus 2 times natural log of 6 equals the natural log of 16. Okay. Also, before we took the natural log of both sides, maybe one thing we should have done is approximated our answer. What should our answer be? 6 to what power is 16? Well, we know it's going to be 1 point something. Okay. All right. So moving forward here, we want to get rid of the natural log of 6. So let's divide both sides by natural log of 6. Those reduce. We get x minus 2 equals the natural log of 16 over the natural log of 6. And again, this is just going to give us some number. Okay? I want to punch that in my calculator, but then to get x completely by itself, we want to add 2 to both sides. So we want to get that number and add 2 to it. Okay? All right, so let's see what our answer is going to be. And again, it should be 1 point something. There we go. Good enough. All right. So we get natural log of 16 divided by the natural log of 6. And then, yeah, like we said, it's 1 point something. But since we're subtracting 2 from our exponent, next we need to add 2 to both sides. So plus 2 to our answer. And we get 3.547. So then x approximately 3.547. And then, yeah, that's right, because again, with our exponent, we're plugging in 3.547, but then we're subtracting 2 from it, so we do get that answer of 1 point something, just like we expected. All right, sorry, there's all of our work, and we're moving the page a little bit. And then that wraps up the 9.7 notes.